Good day to all. Now I am going to explore about fundamental concept of data structure. What is data structure? Data structure are the fundamental building concept of programming language. That means they have defined how the data is organized and stored and manipulated within the program. What is data structure? Data is a collection of information. The data structure is a storage that is used to store and organize in data. That means it is organized in a sequential way, that it is used to access and update the data efficiently. Data structure is not only used in the organizing the data, but it is also used to the storing and retrieving the data. Next one, classification of data structure. Data structure is classified into two types, then linear data structure and non-linear data structure. Again, linear data structure is divided into two types, then static data structure and then dynamic data structure. The static data structure supported by arrays and the dynamic data structure is supported into queue, stack and then linear list. Then non-linear data structure is supported into the trees and then graphs. And linear data structure. What is meant by linear data structure? Does a linear data structure is arranging the elements in a sequence way. That is a linear data structure. Static data structure. What is meant by static? Static is a fixed one. So the static data structure is as a fixed memory size. It is a easier access and then element in a static data structure. For example, array. Then dynamic data structure. Dynamic data structure is a size is not a fixed. Dynamic means it is not a fixed one. So dynamic data structure is a size is not fixed. It can be randomly updated during the runtime. For example, queue, stack and then etc. Then non-linear data structure. Non-linear data structure means where the data element is not placed in the sequentially or linearly. It is called as a non-linear data structure. The next one is array. Array is a collection of array is a collection of item of the same variable type. That means same data types. Then the elements are stored at continuous memory allocation. The types of arrays. The arrays divided into three types of arrays. First one is a one-dimensional array. Second one is a two-dimensional array. Third one is a multi-dimensional array. First one-dimensional array. One-dimensional array means store the data in a single row. For example, int array of 5 is equal to element 10, 20, 30, 40 up to 50. Why it is fixing means int is a data type. An array is array of 5 is a capacity. So capacity of the values and the index value is 5. So we can store the 10 to 50. We can store the 5 elements in an array. First, second one is a two-dimensional array. Two-dimensional array means it will store the data in the row and then column wise. For example, it is supported to the matrix format. Int matrix of 2 of 3. In the matrix 2 is denoted as the row, then matrix 3 is denoted as the column wise. So the values is 1, 2, 3 and then 4, 5, 6. Then next one is multi-dimensional array. Multi-dimensional array, it is used for complex applications like 3D applications. For example, arrays with more than 2 dimensions. More than 2 dimensions. For example, int array of 2, 3 and 4. Next one is stack operations. What is meant by stack? Stack is a linear data structure. It follows the LIFO principles. LIFO means last in, first out. The element ordered last is removed first. It is like a stack of plates. We are considered the taking some plate. We are arranging some plate means first last one is the take out the first plate. So this is the stack operations. For example, stack operations we are classified into the 5 types. So first one is a push-off method, then pop-off, Second, next one is empty, then is full, and then last one is takeoff method. First one is the push-up method. Push means it added element to the top of the stack. That means insert an element. Add element to the top of the stack. If the stack is full means it causes the stack is overflow. So suppose the stack is empty means we can add into the some element into the stack. For example, stack of plus top is equal to item. Then push operations. We can consider the empty stack. Empty stack means which means top is equal to minus. Whether the top is equal to -1 means if the stack is empty. Then next one is push of A. Then A is insert into the stack pointer. Then push of B means another value of the B element added to the stack pointer. Then push of C means another value inserted into the stack pointer. Then D. The stack is full. Next one, pop operation. Pop means remove or return the element to the top of the stack. If the stack is empty now, it causes the stack is underflow. Where it is stack is full means it causes the stack is overflow. If it is stack is empty means it causes the stack is underflow. For example, stack is equal to stack top minus. For example, we are consider the pop element. First one stack is full. We are in 4 element into the stack, so the stack is full. Then pop of 40 means so stack follow the principles of LIFO, so last in first one. So first element, last element going to out in the first one. So pop of 40, so remaining pop element is 10, 20 and then 30. Again we are popping the another element, so 20 is popping. So consider remaining element is 20 and 10. The top is equal to 10 means pop is equal to 10 means top is equal to -1. Then if having no element means if the stack is empty. The next one, peak. Peak means return the top of the element. That means we can return the top of the element without removing. That means we can see only the top of the element into the stack. For example, top or peak means we are considering the 4 element into the stack. First we can see the top of the element. If the top of the element is present in the 40. So next one is empty of check whether the stack is empty. If returns if top is equal to -1 abina. For example, if it is the we are taking the stack operations 40, 30, 20 and 10. This is the stack. If stack is equal to false, this statement is true because stack is full. So stack is empty is equal to false is correct. Then next one is stack element. Then is empty is equal to true. This is a true element because top is equal to -1. That means stack is empty. So is empty is true. Then is full of. Check whether the stack is full. So we are going to check whether the stack is full or empty. Then return top is equal to max size -1 is full operation means we are considering the stack element into we are considering capacity is equal to 4. 4 means 10 to 40. So is full is equal to true. This statement is true. Then stack capacity is equal to 4, top is equal to 10, 20 and then 30 elements are present. Only 3 elements are present. So now the statement is false. Next one, applications of stack. First one, expression, evolution and conversion. That means we are converting the infix into the postfix or prefix into the postfix. Then function call, management, then undo and redo functionality, parenthesis matching and backtracking algorithm. Backtracking algorithm we are using the Bustle methods. Next one, queue operation. Queue operation is queue is a linear data structure. It follows the before principle. Before means first in, first out. The element inserted first is removed first. For example, just like people standing in a line. Now we are consider the standing in a line means who is standing in the first one. that people go out, send out the first. So this operation is following the queue operations, where basic queue operations NQ and then DQ operations. NQ means just like a push operations. Add an element at the rear position, and then if the queue is full means it passes the queue is overflow. If the queue is empty means it causes the queue is underflow. For example, rear plus plus q of a is equal to item. The next one DQ. DQ means removal. DQ element is related to the pop element. This is equivalent to the pop element. It removes an element from the front of the queue, opposite of the NQ operations, which is ordered. This is the front position and the rear position. We can add into the rear position, we can remove into the front positions. This is the TQ operations. Next one, tree in a data structure. What is tree? Tree is a non-linear data structure. Tree is a non-linear data structure. It is a hierarchical data structure. Then this is used to represent the relationship that have the parent and the child relationship. For example, the basic terminologies. First one, node is nothing but is an entity. That means it considered as a data and the value. Root means a single topmost element into the tree. Then parent node that has parent node means that has one or more child node. Then next one, child node. Child node is a node connected to the parent node. The leaf node means a node that has no children means that is called as a leaf node. Then subtree. Subtree is a portion of the tree that contain itself we consider as a tree. Next one, this is a tree. This is the topmost element. It is called as the root node. This each and every one is a node. Then a parent node D and D is a parent node and B is a parent of T and E. And then D is a parent of H and I. Then this is the subtree. This is the whole we are considering it a tree. This part is also called as the subtree. Then next one is a C. C is this is the level. This is the level 0 and level 1, level 2. Then siblings. Siblings means more than two children in the same parent. That means F and C is a sibling. So F and C is a same parent of the C. Then leaf node means they have no children means that is called as a leaf node. So basic operations of the tree data structure. There are three basic operations. The first one is the create operation, insert operation, and then search operations. First one is the create operation. Create means create a tree in a data structure, and then insert means insert the data or insert the value into the trees. Then search means search the specific data in a tree to check whether the data is present or not. Then tree traversal. There are two types of tree traversal. First one is a depth first search tree. Second one is the breadth first search tree. Tree traversal means in the process of visiting all the nodes in a tree data structures. First one is a depth first search tree. So method of traversing a tree. There are three types. Three main types. First one is a in-order tree traversal, pre-order tree traversal, and then post-order tree traversal. In-order tree traversal means first visit the node into the left subtree, then next visit the root node and current node, then in last visit the right subtree. In pre-order traversal means first visit the current node, then visit the left side and then visit the right side. Then post-order traversal, first visit the left side and then visit the right side, last one visit the current node. Current node, that means a root node. Next one, in-order traversal. In-order traversal method, left subtree is visited first, then root subtree, and then last one is a right subtree. In this order, this is considered as a tree. Then A, B, and C. These are all the nodes. First visit the left subtree. So A order for subtree of A is B. Left subtree of A is B. Then the B is also traveling in order. So the last left subtree is a T. So in order to T, B, E, A and F, C and G. This is the way of visiting left subtree and then visit the current node and visit the right subtree. The next one, pre-order traversal. Pre-order traversal means in this method, first visit the root node and then visit the left node and then visit the right node. For example, this is the root node. A is the root node. B and C is the child. B and D and E is the parent of B. This is considered as the left subtree and this is considered as the right subtree. Then we are following in this order. First visit the root node. So we are first visit the current node. So node is A is present here. Then next is visit the left subtree. So A is the left subtree is B. Then B is also travels in a pre-order. So is the left subtree is B. Left subtree is a D. Then right subtree is a E. Then next one, current node is a C. And then right subtree and then left subtree of F and G. Next one, post-order traversal. Post-order traversal means in this traverse method, visiting the last. So first one, visit the left subtree and then visit the right subtree and last one visit the root node or visit the current node. And we start from the A root node. So first one is visit the left subtree. So left subtree is, last one is T is present here. So T is the left subtree. So T and then right subtree is E. So next visit the right subtree. Then E is present here. Then last one visit the current node or visit the root node. Root node means B. So D, E, B. So next one is, and the current node is A and then left subtree is C and F4. So F is a left subtree. Then right subtree is G. Then current node is C. The last one current node is A. A is the current. In this order we will display the post order traversal. Then we will see the next slide. Thank you.